Series and parallel circuits. Electrical circuits are pretty useful things. They enable us to use electrical energy effectively and efficiently to power all sorts of different devices. There are two main ways we can wire up our devices to get the closed circuit required for an electrical current: series and parallel. In a series circuit, all your devices are queued up one after the other in an ordered sequence. Think about it like binge watching a series on Netflix. All the episodes come one after the other. Because all the components come after one another like this, the voltage is shared and is different around each part of the circuit. Each component requires energy, so the voltage changes. Think about it like walking around a loop in school with a packet of biscuits. Every time you see a mate, you'd probably give them a biscuit, and therefore some energy, and the amount of biscuits that you had would change throughout your walk. The current in a series circuit, however, is same. This is due to the fact there is only one loop of a circuit, so the flow of electrons at any point is going to be the same. It's like having one circuit for everyone to walk around. There's always going to be the same number of people going through any point. The other type of circuit is a parallel circuit. This is where not every component is on the same loop of the circuit, and each device might have its own different loop. Here, because each component has its own loop, the voltage is the same for each loop. This is because each circuit might be connected to the battery or the cell, so it can deploy its full energy reserves in each loop. Like you do the biscuit walk again, but each time you see a mate, you can go and get a whole new packet of biscuits from the dining hall. The current in a parallel circuit is however different. As there are different paths for the electrons flowing around the circuit to take, the numbers flowing past each point is different, so the current is different. The resistance is also affected by what type of circuit it is. Remember, resistance is the wire fighting back against the electricity flowing through it, with the electrons hampered by the ions in the metallic structure. If your components are in series, then the resistance will add up. It's like running the gauntlet in Gladiators. The resistance from each opponent adds up, and so does the resistance in each component. So, if you see resistors in series, which is a very common exam question, the resistance is simply added. In a parallel circuit, however, the resistance is a little bit more complicated. You can think of it like the different loops offering different paths or options for you to go down. More electrons might choose the path of least resistance. And this means that the overall resistance is not a straight addition. Rather, it kind of falls between the maximum and minimum resistance. Now, what are their uses? Parallel circuits have some form of protection against failure, which is why they're pretty useful. If a bulb breaks in a parallel circuit, it will stop the current flowing in that loop, but the other ones are unaffected, so this is useful for things like headlights, as it's better to have one out than to be plunged into darkness on a country road. Secondly, as the voltage is the same throughout, the brightness in the bulbs will remain the same, so you'll get bright lights. In a series circuit, as the voltage plus energy is kind of shared out, each bulb added will reduce the brightness. However, series circuits are also handy because of their simplicity. If you make Christmas lights in a parallel configuration, although you'd be protected from all your Christmas cheer evaporating into dust if one of the bulbs fails, you'll have to have an individual wire loop for each bulb. And so the fairy light chain will have hundreds of wires and be really thick and ugly, and probably cause the tree to break in and have a 4-year-old's children's gift just crushed to nothing in front of them. Finally, the exam boards love to talk about voltmeters and ammeters in terms of their series and parallel circuits. As ammeters measure the current, they must be placed in series in the circuit. Think about it. If you wanted to measure the flow of water in a river, you need to get in that river and actually feel the flow of water past you. So ammeters need to get in the loop and be in series. This also means that they need to have almost no resistance, so as to not actually affect the circuit. Voltmeters, however, are measuring the voltage or potential difference between 2 points in the circuit. If you want to compare those 2 points, you're going to need to take a step back and kind of have a look at both at once. Therefore, voltmeters are placed in parallel across the component you want to measure. This is so that they can look at the both points from the outside and kind of compare them. In summary then, series circuits have the same current, different voltage, and the resistance adds up, and are useful for simple high current applications. Parallel circuits have different currents, but the same voltage. The resistance is more complicated, but it roughly kind of falls between the maximum and the minimum of each loop. It's useful to cope with failures, and ammeters are connected in series and voltmeters in parallel. Questions. What happens to the current in a series circuit and in a parallel circuit? Also, what happens to the voltage in a parallel circuit? What type of circuit would be useful in my house? And finally, if you have two 5 ohm resistors and a 3 ohm resistor connected in series, what would the total resistance be?